Hello everyone and welcome to the dev method. So today's episode we're going to take a look at integrating a C++ module or program into a Node module in NodeJS. So this example is up online. It's ready for you guys to look at. So let me show you the website first and we will walk through the code. So instead of coding live with you guys and you watch me go through that, this is going to be more of an explanation of what's there so you guys can go and learn and maybe explore and try some of this stuff out on your own. The first thing I want to look at is the code here. This is on rickypowell/fast-js. And the example C++ code is in the src folder. It's called hello.cec. And then we have a couple of just, normal boilerplate Git repository stuff. So we have a git ignore, a license. There's the README, which you can read here on the website as well. We'll go through that in a bit. Another big one here is the main.js. So this is just like a test to see how it all works together after everything's ready to go. And then there's the package.json file. You guys can take a look at that as well. Essentially, that's just saying what the name of this repository is, and then a couple of scripts that we'll need to run to just get the project ready to go. So one of the things about Node that you might have noticed when you're writing a new web application, so maybe it's Ember, Angular, Vue, there's always some sort of like npm install command that you run. So here we can do the same thing and it gets us all ready to go. It actually is the second step after you have Node installed on your computer. So this current example, I used Node 9.8. So you can get that in a couple different ways. You can get on Node's websites. They have a list of all the different versions. But once that's installed, then you could do npm install on the current directory. So on this project here, which will then give you a built project, and then you run npm start to just run the project. So after you have that, the idea here is, as it explains, we're comparing the speed against looping over a large number of items. And some of the things that it's doing, it's iterating over this really large count. It's changing the value of one particular local variable that's in scope. And then we are printing the string hello with a new line character to standard output. So that's what is going on. So let's first look at some of the code. I actually have it right here. And we'll take pit stops along the way just to see what this code actually does, maybe explain more details of it. But the first part I want to show is just the main.js, so you get an idea of what's happening here. My text editor is showing some of the suggestions about what these things are, what they could mean. The first thing that pops up here is a couple of require statements. If we just look past that for a moment, we're going to look at the first little section here, and this is just showing us a C++ hello time. So there's this thing in JavaScript, it's actually a really cool tool, allows you to see the time something took between the console.time and then console.timeend. And that's what I'm doing here. You just pass in the same string. It's used as an identifier to JavaScript to let it know that you're done with the time, and it'll actually print that out to standard output. So that's what we're doing there. And then I made a second one, and this is supposed to be doing almost exactly the same amount of work. And I say almost because it's written slightly differently in JavaScript. And the whole point here is just to see what the differences are between the two languages, and then also the difference in performance between the two. And then at the very end, I just say that, we're finished here. So this is our start to the project. And then I'm just going to run it so you can see what it does. So if I do a npm start, here it goes. All right, so here is when it says hello. and then it says C++ hello took 0.136 milliseconds. And then we print hello again, this time with JavaScript. And then we have it lasted actually 3.586 milliseconds. So definitely a big difference there. Just to show you what the code looks like in C++, we'll look at it side by side. So this is the code we want to look at here, right, from line 13 through 16. Oh, and through 17, sorry. Lines 13 through 17. And then notice on the right-hand side, this little body of code is exactly the same thing, but the C++ equivalent. It's slightly different, and it's only slightly different in some very specific language differences. So for example, this is a strongly typed language, the C++ language, and we have here int and count. So we always know it's an integer. And here in JavaScript, we also initialize a count, but it's initialized as a mutable local block scoped variable. And the whole point of this is that this is only the local scope, this is only the local scope, so that's why I chose let in JavaScript. And then we have the for loop, which is almost exactly the same thing. And you can see here, it is actually the same exact thing. It loops just the same amount of times through the for loop there. And this is like a traditional C style for loop. And then we have here the print after the run of this loop. And that's here in C++. This rest of this stuff actually doesn't count when actually running the program. And that's why I looped, or that's why I started this JS loop time on line 12 and then stopped it on line 18. And the whole point of that was that it's supposed to just mimic just this stuff here. So our time, it's like we would do a console.time right in here in between lines 5 and 6, and then right after 11 and in between 12 there. So that's the whole point of that. The rest of this stuff is just like code, like setup configuration to get it into a JavaScript module. But that's a look at the two differences between what it is we're testing here. Let's go back up to the top of the JavaScript file just for a moment. I just want to point out a couple things. I'll make this a little bit bigger. So the first thing I did, this was just a test for me since I was experimenting. I wanted to make sure that nan was available. So let's talk about nan. And it says that like nan finished, right? So nan is actually part of NodeJS. And it is known as the native abstractions for Node. So NAN, native abstractions for Node. The cool thing about this is actually you use this in your C++ programs, and you'll see right on the GitHub website, there's nan.h. So this here is everything that I would see when importing nan. So it looks at the different node versions, and then it's got all the implementation of everything I need. Now let's take a look at where we could find some of these node abstract, these native abstract node of Node. Is that what it was called? What was it called again? It was called native abstractions for Node. Yeah, the nan. Let's look at that. So here, this, it's telling us that, let me go to the definition. There we go. It's like this define. It's like a macro. So the whole point is like it's the method and then the name of it, and then it actually underneath the hood is actually doing this right here. So kind of cool that hello here is the name, and then we're actually reaching inside of this module init. Okay, And we're registering these where it says set methods. So these are the different functions. So let's take a look back at the main.js. So when we're doing the require of nan, that was just a test to make sure it's actually there. So it's not really needed to run the rest of this. So I could take this out and it'd be just fine. But this is the real thing here on the right-hand side. This is our require statement to get the hello function. So when we run npm install, what's happening, I'll show you the code for this. All right, so when taking a look at this, this set method part here, this is the import of nan. This is a namespace here. So what we're saying is nan, and then it's like set method. And what we do is we pass in just target, which is a name there again. Then we give it a string of what we want the function to be inside of JavaScript. And then this name, again, just to identify that whatever was the method name up here registers back to this same name here. And then we have the node module, same name again, hello, and then init, which is like from right here. So I'm not a big C++ person, so I can't tell you much more than what I see here. If you guys have any other comments or feel like I've left anything out, put those in the comments below for this video, and everybody can learn from it. Now, the next thing here is if I wanted to change this implementation, like for example, do, I don't know, another like print to standard output, just do something like this. If I did that, the only thing I need to do to update it, rebuild. That runs my rebuild that I put in there for you guys. So notice it's got this CXX target, and then it put it as release, and then object.target, and then it was hello, and then we have source, and then hello.o, that's the object file in C, and then we have so link module on the target, and then in release, hello.node. So how does a node glue those things together? That's actually a different part of this project. That is the binding.gyp file. So the binding.gyp file has a minimum setup of targets with an array of objects. And here we have the target name, its sources that it needs, and then the include directories, or DIRs as they say for short. Now, what we're doing here is actually just running node just to make sure that nan does exist. Otherwise, we would fail. That really helped me out because I noticed Visual Studio Code isn't always giving me the correct errors in the text editor here. It's saying it can't find nan, but it's actually really there because everything compiles just fine and works as expected. So what I recommend is playing around with this, make a couple different files, add them in. Something I've done before is, just add something here, src, and you could do another file, right? Now this one, if I was to make a new file here, just say, I don't know, let's see, add ricky.cc, okay? Now, if I run this, not totally sure what's going to happen, but run rebuild. It's got nothing in there, but it should build the file. Yeah, builds the file just fine. Now I'm going to remove it. And I'll do the same thing. Rerun the build. Oh, got an error. Oh, yeah, so the other thing I have to do is remove this. So if I have a file missing, notice that the build has failed. Here we go again. And there it goes. All right, cool. So it puts it in this target name, right? Now, in the main.js file where I'm using this, all I had to do was do a require. And I'm actually doing a require to a relative path. See here I have dot slash, so that's relative path. So this current path is just the root to the build, to the release, to this hello.node. So if I change the target to be something like cheddar, then it would say cheddar.node. Let me give you an example of that right now. So cheddar. Here we go. Ran, see, cheddar.node. Okay. Now if I run my JS, it actually will not work. Here's what happens when you get something wrong, like the wrong name. So npm start. So it'll give you this stack trace, but it's actually in Node. It's a stack trace from Node, and it's saying it's throwing an error, and that's because there's this like loader that's not working. So it's saying it can't find the module release hello node because it doesn't exist there. So it's actually cheddar, right? Now I start it up again, and it works just as it did before. So let me revert that real quick. And just to double check, I'll rebuild. Sweet. And then run. There we go. So thanks for checking in today. Hope you enjoyed the video. Hope it was educational enough for you guys to just start programming in C++, make it available in JavaScript. You saw that there was also performance gain that we get from this too. It's not all the time that you'd want to be doing your C++ and then using it in JavaScript. Sometimes it's actually a lot quicker to do some sort of business logic or an algorithm in JavaScript rather than in C++. But as you can see, there are some performance gains. So if you're working with a large amount of data, that's going to be something you want to do. There's also a lot of C++ libraries out there that you could take advantage of, just like there are JavaScript libraries, of course. But the C++ ones will run faster, as you can see. And you might find some ones here that do a little bit more than what Node gives you out of the box. So that's something I would recommend looking into. Just so you get an idea, some people who actually do this. So an example library that does this is actually NodeSAAS, so Node-SAAS. If you've ever used Webpack to transpile your SAAS into plain CSS, like finally build it so that you can use it in your project and bundle it all together as a single application, this has probably been used whether you knew it or not. So NodeSAAS here, if you take a look at their repo, they have here 82.4% C++. And I know that they're using the same technology that I just demoed you because if I look down below, I see this, binding.gyp. There's a lot more to this than there is my file that I created, but notice there's this binding.cpp, and then there's this .cpp, and then this, and then this, and then this, and then this. Makes me wonder here too, is it .cc or .cpp? Real quick, let's look it up. So, C++ file extensions. Boom. .c versus .cpp. At the end of the day, it doesn't matter because C++ compiler can deal with the files in either format. If it's a real issue for your team, flip a coin and move on to the actual work. All right, well, that settles that. Rarely do I ever stumble upon something quite as funny as that on Stack Overflow. That's pretty cool. There's a lot of other cool things here. It looks like the target name is just binding. That's fine, I guess. And then I know that there are different like Xcode settings. So something that we didn't go over that I know you can customize is like which version of C++ you're actually using. So for example, if you want to use make unique, you're going to have to specify some of these extra settings so that instead of C++ 11, it's C++ 14. There's another part here too that I think might be needed. Let me skim through this real quick. Yes. So this one is saying if the OS is not Windows, this STD version, it's giving it a C++ version here. I think that also has to be set to 14 as well. I can't be too sure on that, but just be aware if you want to use specific versions of C++. Right now, if you're developing on your Mac, you're going to see that it uses C++ 11, which you'll have unique pointers, but you will not have make unique, which was introduced in C++ 14. So be aware of that. That's something to look at here. If you want to learn more about this stuff, if you look up NodeGYP, the website, there's actually a bunch of different information here on the repo on GitHub. It probably has some of the information that I was just telling you about, but it also talks about like, if you're experimenting with Python and you install different versions of that on your computer, it's recommending actually setting it back to Python 2.7, which that's interesting. It's about to get set to Python 3 or something in the 3 category with Mac OS 10 Catalina. And then let's see, here's like how to use it, set up the configure if you're going to start your own project. Quite a few different things. Talks about configure, build, and also this newer command, which is rebuild. And then it shows you here the very basic setup that that I got. I know running configure, though, helped me set up a bunch of these things for me. It's got a list of the commands that you can run. So it's very, very helpful if you're going to be experimenting. I know I'll be using it. So if you have any cool tips that you want to share with other people, also add that to the comments. So that's all we have for the show today. Thanks very much. I'll catch you guys later.